Lesson 3.11, Scatterplots and Correlation. Our objective for this lesson is to be able to make a scatterplot for a set of data with two variables and describe how the two variables appear to be correlated. First, let's define scatterplot. A scatterplot is a graph in which each point represents the values of two variables. So with the data that we're looking at here, we've got two different quantitative variables, and we want to compare those two and see if there's a relationship between the two. As one variable increases, does the other variable also increase? Or as one variable increases, does the other variable decrease? And so to create this scatter plot, we put one variable along the x-axis and one variable along the y-axis, and then we plot each data point as a dot where those two variables will meet up. And so what we end up with is a graph with a bunch of dots on it that aren't connected by lines, and this is called a scatter plot. So we use the scatter plot to look for a correlation between the variables. So correlation is a measure of the strength of a relationship between two quantitative variables. So again, we're looking at two quantitative variables, and we want to see, does one variable, as one variable increases, does the other variable also tend to increase? Or as one variable increases, does the other variable tend to decrease? And we want to see how closely related these two variables are. That's why we create the scatter plot, because it helps us to see if there's a relationship, and that relationship is called a correlation. So let's talk about the relationship between two data variables. A positive correlation means that both variables tend to increase or decrease together. So an example would be height and weight. As your height increases, your weight will tend to increase as well. So that would be a positive correlation. With a negative correlation, the two variables tend to change in opposite directions, with one increasing while the other decreases. So an example of a negative correlation would be elevation and temperature. The higher your elevation, the higher above sea level you are, the lower the temperature is going to tend to be. So that's negative correlation. And finally, the strength of a correlation. So the more closely two variables follow the general trend, the stronger the correlation, which may be either positive or negative. Of course, it's possible that there's no correlation between the two variables. And if you did a scatter plot with no correlation, you would see that there's no general trend. There's just it's just random. A perfectly strong correlation would be one where you could draw a straight line through all of the dots. That would be a very strong correlation. And then the farther away those dots would get from that line, the weaker that correlation is going to be. So let's look at some examples of different types of correlation. In this scatter plot, it's obvious that as this variable on the x-axis increases, the variable on the y-axis is also increasing. In fact, you could almost draw a straight line through all of those dots. And so this would be an example of a strong positive correlation. In this example, you can see that there's a general trend that as this variable increases, this variable also increases. But it's not as obvious. The dots are much more spread out. So this is going to be an example of a weak positive correlation. For this example, there's no general trend, either positive or negative, with these dots. So we would say that this has no correlation. Here, as the variable on the x-axis increases, the variable on the y-axis seems to be decreasing in general, but it's not obvious. The dots are pretty spread apart. So this would be an example of a weak negative correlation. And finally, this would be an example of a strong negative correlation. You can see that as the variable on the x-axis increases, the variable on the y-axis is clearly decreasing. And all of the dots are clustered pretty closely along a line with a negative slope. So this is a strong negative correlation. For our example, we were given some data that we were told represents the literacy rate and the infant mortality rate for 10 countries. And we were asked to create a scatter plot and then to determine what type of correlation exists between these two variables. And so you can see here, I've plotted all this data on the scatter plot, where we've got this point here representing Afghanistan and this cluster down here representing the United States and Germany and New Zealand. So we can see from this that there's a negative correlation between literacy rate and infant mortality rate. That is, the higher the literacy rate in a country, the lower the infant mortality rate is going to be in general. And this is a fairly strong correlation. You can see that you can almost draw a straight line that would touch or come very close to nearly all of these data points. There's a couple of exceptions. Burundi has a relatively high literacy rate, but also a very high infant mortality rate. And Ethiopia here has a slightly lower infant mortality rate than we would expect, given that their literacy rate is just 49%. But overall, this is a fairly strong negative correlation.